Hey guys, welcome back. So today we'll be reducing rational expressions to lowest terms. One thing to keep in mind when you are reducing your rational expressions is to remember the cancellation property. And this pretty much means that if you have A times C over B times C, I can cancel my C's and I will be left with A over B. So let's plug in some numbers. So let's say we have x squared minus 1 over x squared minus 2x minus 3. If I have to factor my numerator, I'm going to be left with x minus 1 times x plus 1. And then my denominator, I'm going to look for two numbers. When I multiply, that's going to give me a negative 3. Those same two numbers, when I add them, needs to give me a negative 2. And that's going to be negative 3 and a positive 1. So I'm going to do x minus 3 here, and then x plus 1 here, because if I multiply negative 3 times a positive 1, I'm going to get a negative 3, which is what we have here. And then if I add negative 3 plus 1, this is going to give me negative 2, which is what we have here. So I know my factored form is going to be this expression here. However, based on the cancellation property, I can cancel my x plus 1, and I'll be left with x minus 1 over x minus 3. So it is important to understand that the rational expression is reduced to lowest terms by completely factoring the numerator and the denominator and canceling out any common factors by using the cancellation property. So let's look at our first example. We have x squared plus 4x plus 4 over x squared plus 3x plus 2. So the first thing I'm going to do, we're going to factor my numerator. I need two numbers. When I multiply together, that's going to give me a 4. Those same two numbers, when I add, has to give me a positive 4. And that's going to be x plus 2 times x plus 2. Because if I multiply 2 times 2, this is going to give me a positive 4. And if I add 2 plus 2, this is also going to give me a 4. Let's look at my denominator now. I need two numbers. When I multiply, that's going to give me a positive 2. Those same two numbers, when I add, has to give me a positive 3. And that's going to be the numbers 1 and 2. Because if I multiply 1 times 2, this is going to give me 2. And if I add 1 plus 2, this is going to give me 3. So the numbers I'm going to use is the numbers 1 and 2. I'm going to do x plus 2 here, and then x plus 1 here. Now, based on the cancellation property, I'm going to cancel my x plus 2, and I'm going to be left with x plus 2 in my numerator over x plus 1 in my denominator. And this is your final answer. Let's look at x cubed plus 5x squared over x squared plus x. So let's look at our numerator. I'm going to factor out my x squared. If I factor out an x squared, I'm going to be left with x plus 5. And remember, if you were ever unsure if you factored correctly, you can always multiply back to make sure that it takes you back to your original problem. So if I have x squared times x, this is going to give me x cubed, and then x squared times 5, this is going to give me a positive 5x squared. So we know we factored this correctly because it takes us back to our original numerator. So now let's look at my denominator. Let's factor my denominator. Common factor, if I factor out an x, I'll be left with x plus 1. So let's go back to our numerator. Notice here I do have x squared, which equals x times x, and then you have your x plus 5 in your numerator. And then my denominator, we have x times x plus 1. And in this example here, we can cancel out one of the x's here, and I'll be left with x times x plus 5 over x plus 1. And this is your final answer here. And remember, you can leave your answer like this in factored form, or you can multiply it out. So you can write your answer in either one of these forms. Let's try x to the 4th minus 8x over x squared minus 2x. So I'm going to go ahead and factor my numerator. I can factor out an x and I'll be left with x cubed minus 8. In my denominator, I can factor out an x and I'll be left with x minus 2. In this example here, notice here we have the difference of two cubes. So this is going to equal x times x minus 2 times x squared plus 2x plus 4. And then my denominator, we have x times x minus 2. So I can go ahead and cancel. I can cancel an x. I can also cancel my x minus 2, and I'll be left with x squared plus 2x plus 4. So this is your final answer. Let's try 6x squared minus 12x over 2x minus 4. My numerator, I can factor 6x. If I factor 6x, I'll be left with x minus 2. My denominator, I can factor out a 2. If I factor a 2, I'll be left with x minus 2 as well. And according to the cancellation property, I can cancel out my x minus 2. I'll be left with 6x over 2, and 6x divided by 2 is going to equal 3x. So your final answer here is 3x. Let's look at x squared plus 3x plus 2. And then my denominator we have, let's do x squared plus 2x. So let's factor our numerator. I need two numbers. When I multiply, that's going to give me a 2. Those same two numbers, when I add, has to give me a positive 3. And those numbers are going to be 2 and 1. If I multiply 2 times 1, this is going to give me a positive 2. And if I add 2 plus 1, this is going to give me a positive 3. So I'm going to do x plus 2 in my numerator times x plus 1 in my denominator. Let's see, we can factor out an x. If I factor an x, I'll be left with x plus 2. So based on the cancellation property, I can cancel my x plus 2, and I'll be left with x plus 1 over x. And this is your final answer. Let's look at x cubed plus 8 over x squared minus 4. So notice here we have the sum of two cubes here, and we have the difference of two squares here. So my numerator, this is going to give us x plus 2 times x squared minus 2x plus 4. My denominator, we're going to get x minus 2 times x plus 2. I can cancel out my x plus 2 here, and I'll be left with x squared minus 2x plus 4, and this is going to be over x minus 2. And this is your final answer. So let's look at this example here. The first thing we want to do is to write our numerator in standard form. So if I write my numerator in standard form, this is going to look like negative x squared minus x plus 6. And that's going to be over x squared minus x minus 12. Notice here, when I rewrite my expression into standard form, we now have a leading negative number. Since we have our leading negative number, I need to factor out my negative 1. If I factor out my negative 1, I'll be left with x squared plus x minus 6. Notice that all the signs in here changes. That's going to be over x squared minus x minus 12. So now let's continue factoring if we can. So we need two numbers. When I multiply, that's going to give me a negative 6. However, when I add those numbers, those same two numbers have to give me a positive 1. So that's going to be 3 and a negative 2. If I multiply 3 times negative 2, I'm going to get a negative 6. If I add 3 plus negative 2, this is going to give me a positive 1. So my numerator, we're going to get my negative 1 here, and then I'm factoring my x squared plus x minus 6. We said that's going to be a 3 and a 2, so I have x plus 3 times x minus 2 in my numerator. My denominator, I'm looking for two numbers. When I multiply, that's going to give me a negative 12. those same two numbers when I add has to give me a -1. So those are going to be 4 and 3. If I have a -4 times 3, this is going to give me -12. And if I add -4 plus 3, this is going to give me -1. So my denominator is going to be x minus 4 times x plus 3. And I can go ahead and cancel my x plus 3 here. So I am left with my -1 times x minus 2 in my numerator. And then my denominator, I'm left with x minus 4. And this is your final answer. And notice here, because we have this -1 on the outside, you can rewrite this different ways. You can write this as negative x minus 2 over x minus 4. You can rewrite it as negative x plus 2 over x minus 4. Or you can rewrite it as 2 minus x over x minus 4. And you can also rewrite it as x minus 2 over x minus 4. So these are some of the answers you may see when it comes to this answer here. So all of these are the same answer. So let's try 36 minus x squared over x squared plus 6x. First thing we're going to do, let's go ahead and turn our numerator into standard form. Let's rewrite this into standard form. So we have negative x squared plus 36. And then my denominator, it stays the same as x squared plus 6x. And now we have a negative leading number. So I'm going to factor this negative out, and I'm going to be left with x squared minus 36. And then my denominator, I can factor out an x. I'll be left with x plus 6. And notice here we have the difference of two squares. So this is going to be -1 in my numerator times x plus 6 times x minus 6. My denominator, we have x times x plus 6, and I'll be left with -1 times x minus 6 over x. And this is your final answer. Let's try x squared plus 6x plus 9 over 9 minus x squared. So I'm going to factor out my numerator if we can. Let's try. We're looking for two numbers. When I multiply, that's going to give me a 9. Those same two numbers, when I add, has to give me a 6, a positive 6. So those numbers are going to be 3 and 3. Because when I multiply 3 times 3, I'm going to get a positive 9. And if I add 3 plus 3, I'm going to get a positive 6. So my numerator, we're going to get x plus 3 times x plus 3. My denominator, we're going to write this in standard form first, and then we're going to factor out. So I'm going to change this into x squared plus 9. And notice I do have a leading negative number here. So I need to pull that -1 out. So we have x plus 3 times x plus 3. And then my denominator, we have our -1 that we pulled out. I'm left with x squared minus 9. Notice here we have the difference of two squares. So my numerator, we have x plus 3 times x plus 3. That's going to be over my -1. And then x minus 3 times x plus 3. Because I factored out my x squared minus 9 into x minus 3 times x plus 3. So I can cancel out my x plus 3, and I'll be left with x plus 3 in my numerator over -1 times x minus 3. And this is your final answer. So let's look at one more example, x squared minus 5x plus 6 over 2x squared minus x cubed. So we're going to go ahead and see if we can factor. I need two numbers. When I multiply, that's going to give me a positive 6. Those same two numbers, when I add, has to give me a
-5.
-3 times -2. -3 times -2 is going to give us a +6, and -3 plus -2, this is going to equal a -5. So my numerator, we said, was 3 and 2. I'm going to have a x minus 3 and an x minus 2. My denominator, we can factor out x squared, and I'll be left with 2 minus x. Okay, so let's go ahead and rewrite this 2 minus x into standard form. So my numerator, we have x minus 3 times x minus 2 over x squared times negative x plus 2. I have a leading negative number, this negative here. I need to factor this -1 out. So we have x minus 3 times x minus 2 over x squared times that -1 that we factored out from here times x minus 2. I'm going to cancel x minus 2 here. I am now left with x minus 3 over x squared times -1. And this is your final answer. All right, so that is all for today, and I will see you guys in the next video. Bye, guys.